Hiya guys, and welcome back to A's Workshop. The green jumper's out the wash again, so yeah, it's taking up pride of place here in the shed, as usual. Part 2 of the quill plate. Just one arrival this week. Well, it's actually, how can I describe? The quill plate's been finished for 2-3 weeks, maybe. Yeah, but I'm recording this intro at a later date now that I'm coming to edit the footage and realise I haven't got one. So, there we are. Right, in part 1, I mentioned, or you would have seen me using outside calipers to measure the bore in the centre that fits over the quill, and using it as a comparator against a mic and what have you. So, I didn't have a telescopic at the right size at the time. I do now. Nice start one. So, Gareth, you know who you are. Thank you very much. Right, let's get straight on with it, shall we? So just out of curiosity, I set everything back to the centre point, and if I bring the quill down, it does enter. So, yeah, okay, well, it just shows I didn't make any mess-ups as I went along. Well, so far so good. I had to do a little bit of fettling. There were a few lumps and bumps on this ground surface, so I had to just run the oil stone over a couple of little bumps and nicks. I don't know whether it got bumped when it was being assembled. I certainly didn't bump it. Yeah, it was catching. I could see the scratches on the inside of the aluminium, and basically I knew the aluminium was pretty round. So I stoned off the lumps and bumps on this collar, and then it just slips on. I had to do a bit of fettling of the there's like a nylon piece between the column and the DRO. I had to fettle the sides of that just slightly and put some champers on the bottom so that it would fit up into the slot. So next job to do on this, I need a couple of tapped holes in here because I want to put a bracket on the side to hold a rod to put a clock on with a clamp bolt. I need to slit it at the back and put a clamp bolt through. It's not going to be on and off this. I would imagine it's going to stay on there, so I'm not worried about the clamp bolt being tapped into aluminium. So that's out of the back. And I need a hole on the other side here for my depth stop. So I got the part sat up on its end. Found the centre with a wobble. Picked up that corner there, the corner of the chamfer, as a 0 point. And I'm going to have 2 M5 tapped holes, 15mm, and then a further 40mm, so 15 and 55. So I've just moved across the 15, and as you've seen before, so 4mm spotting drill. Hold on. That's the first one spotted. And the tap-in drill, 4.2. I'm just going to get a depth on this. Probably do about 15mm deep. Set a 0 on my DRO. Did I tighten up that chuck? I can't remember. I'm too busy talking. Yes, I did. Up. Speed her up a bit. What am I running at? 12, nearly 1300 RPM. No reason why I can't go 20mm deep in here actually. I'm going to go 20mm deep. That's the 20. Okay. Get rid of the beard off the end of the drill. I'm just going to pop a little 5mm in there, a couple of mil deep, just to drop the thread below surface. Set, drop. A little bit more, I think. There we go. And ooh, I don't know if I got the travel without moving the head to put a chamfer in here. Let's have that chamfer sticking out a bit further. final job. There we are, chamfer the hole. So move on in the same direction with the DRO. 10 turns would be 30 mil, so 1, 2, 3, 4, 5, 6. That's 30 mil. Another 3 turns would be 39. 1, 2, 3, and a further millimetre. There, lock the table in X. Back up with a spotting drill. And so, a little bit tricky, I just set a square on the bed of the vise here against the radius and lined up a little pointer pin with the edge. So I know that's my 0 point or the edge. Forget exactly, I think that was 23 mil. 23 mil normal, 23.07, I dare say I could get different readings. So I need to come back this way for a centre line to drill a hole. Half a 23, 11 and a half. Yeah, 11 and a half mil. So I've already locked up, remove the backlash, so I'll just wind across 11 and a half mil. So that's going to be 3, 6, 9, 10, 11. 11 and a half mil. Okay, so that is my center of this picked up. I'm already on the center this way, so I'm going to plunge down in. I'm going to change over to a collet. I'm going to plunge down in with a slot cutter now. I already had a 6 mil slot cutter up in the collet chuck, so I'm just winding across the Z from the outside back to my 0. Get it started with that. One, 2, 3 turns back out, and I think I'll go a little bit deeper. So I've got a little pocket in there now, and 5 mil spotting drill, nice flat surface on the bottom. And I tell you what, do up the chuck is always a good start. Right, so used to keyless chucks. Perhaps I'll have to get myself one for this. I don't want, I've got a good one on the lathe. There we are. So that's spotted that 5 mil. Now it's going to be a M6 bolt down through here. What's this drill I've got here? 5 mil. So 5 mil drill. Ooh, I'm going to have to take the head up a bit. Am I on the flutes there? No, I'm not. Just. Ooh, yeah, let's take the head up a bit. Okay. Right, okay, that'll do. That'll give me enough drill hanging out to be able to retract it. Oh, throw my bolt, the only bolt I've got. This is a little M6 bolt. It's going to go down through here. As you can see, it goes well beyond halfway. So yeah, I'm going to drill it down to this depth. Well, I'm going to drill down as deep as I can with this 5 mil drill, which is the tapping drill. We'll have a think about picking up the halfway mark so I can set a depth for the 6 mil or 6 mil clearance drill for the shaft of the bolt. So yeah, give it some love. Try and keep a nice even feed on this. I don't want it wandering. Just keeping the pressure on, taking it nice and gently. Right, so carry on. Now that I'm well down in, I'll just do a series of little pecks, I think. Don't get the swarf build up quite so badly. We should be okay, but it is going to be quite a deep hole, this. It needs a bit more. I'm going to have to watch the jaws of the chuck on the part. So I've just wound the head up a bit more. I've had to drop the drill out of the chuck a bit more because I want to go 50mm deep. The bolt's length is 40, but I want the tapping hole at least 50mm deep. And I've only got 50mm of quill travel, so I've set the head with the quill right up, but I've set the drill just on surface. So yeah, I need to go basically the full length of the quill travel here. Quill travels, I think when I looked at it, about 50.8mm. So I can get it. Where are we? 38, 39. Just keep clearing that swarf. I worked out where my centre line is, and I scribed a little line, only you know, with the scriber. And from the line to that shoulder, or the bottom face of that undercut, is 25mm. So I'm going to use the 6mm drill now as a clearance for the M6. It's a 6.3, sorry. I'll give myself plenty of room. When I touch on that face, I'm going to go down a bit beyond centre. I'm going to go to 27mm. So just start a slow, find a out there. So 27mm down from there. So I'm opening up the tapping drill hole, 5mm, up to 6.3. I'm going to go down to a depth of 27. Just check the bolt. Yeah, so that bolt's going to drop down in there, and there'll be 15mm of tapped hole in the bottom. So I've just tapped the hole. Yes, tricky. As you noticed, I put a 6.3 hole here, and that just clears the body of the tap. And obviously, so no problems keeping the tap square. And as you can imagine, I was going 40 odd mil deep. So yeah, I pretty much had to get the tap into that sort of depth. Luckily, the collet tap holder was good enough to hold it. I had to sort of come up the square towards the end, but I've got it to full depth, and I also put the plug tap in as well. So yeah, that's that tapped, and I just double check myself. If I take the bolt, and it does. There we are, screwing all the way to the bottom without bottoming out. So yeah, that's a functioning clamp. So a few more jobs to do on this. The hole, I've marked out a spot. Where is it? On the other side. I've marked out a spot, not clearly, but I've marked out a spot in the rough area where I want it. I'm going to try and decide on what sort of stud I want to use for the depth stop. I haven't decided on that yet, so I haven't drilled the hole yet. I think while I'm at it, I'm going to drill a couple of M6 holes in the front of here, or M5, maybe a pair of M5s and a pair of M6s, because you never know what I might want to bolt on there in the future. So just squaring up the ends of the block that's going to bolt on the side for the DRO, not the DRO, for a clock. I've got to cut her up. Just going to machine this top surface or back surface. This is the face that's going to sit against the big part we made earlier. Just do a bit of edge binding. There. Set as 0. Let's just do that again. Double check it. Yep. Okay. come off the end. What do I want? 11.5. 2mm is half to 4mm on the end of that, and 9.5 to the centre, so 11.5. That's 3, 6, 9, 11.5. Lock the axis, so that's centre line about, same as I did on the plate. Just a touch on the edge of here. Creep up on it. Okay, so again, lock the axis, set as 0 in the direction we're winding. So there's 0, and my height, my distance this way. In fact, I've got to move my head out of the way. Not my head, a milling head. And I want 15 milling plus the 2 17. So 3, 6, 9, 12, 15, 16, 17 mil. Lock the axis, and I'll just 0 that axis because I'm going to be travelling in that direction. Okay, so my first hole there 15 mil in, and the next hole 40 mil further on, and that will match up with those 2 holes. So I just worked out that I need to be 15 mil deep with a counter bore. So if I just put the counter bore, touch on the rule, set a 0, 16 mil deep from there. We'll try that. That's 10. Come on, off you come. 16. Okay. Obviously I'll have to reset it on the next hole because I'm taking it out of the truck and putting it back in again. But I'll just use the same method. Put a rule under it, you know. Might have to be stuck out a bit more. Yeah, that's less than 50 mil down. I am going to machine across the top of here, so I didn't really need that. Okay, never mind. So move on to the second hole, exactly the same procedure. Final little hole in the end. It's going to be an M6. Well, it's for the clamp screw that's going to hold the rod to the DTI holder. So yeah, 5 mil drill all the way through, the tapping drill for 6. It's going to be an M6 screw. I'm going to put some sort of thumb wheel or what have you on this. It can't be that high that it's going to get in the way of my handle that I'm pulling on to drill, my drilling handle. We'll have a look at it at a later date. So right through with a tap-in drill. Just as I've got it in this orientation, I looked at it and thought I got to put another hole in there at a later date. I thought, well, why not do it now? So I did a quick bit of working out. Decided on a position for it. I'll throw that Allen key on the floor. So it's going to be tapped in the lower half, slit again, and the top half's going to be clearance. So if I get a something like, I don't know, it's not fussy, 6.2, 6.2, why not? Yeah. In fact, I'm going to go 6.3. Let me just have a quick look at the tap. Will it tap all the way through without hitting that shoulder? Yes, it will. So 6.2 will be fine. So the problem I came across with tapping deep into that other body, I needed a clearance on the body of the tap. Get the tap to go deep enough. I haven't got long series taps. So, how thick is that plate? It is, I think it was inch. Yeah, so if I go, we'll call it 26 mil. If I go 13 mil deep from the shoulder, I should be fine. So, again, touch off on the square bit of the drill. There, hit a 0 on my readout. Go down 13. So we'll be just beyond halfway. That's 11, 12, 13. Happy, happy, happy. Oh, drop the chuck key now. And we'll pretty the top of that hole up. So it will be tapped at a later date, but I think I'll probably drill the hole the other way before I slit it. And then after I've slit it, I'll probably tap it. Can I get low enough? Yep. So that's that hole. So the little rod that's going to be the depth stop, I wanted something with a 1 mil pitch, so 1 rev of the nut is, you know, a millimetre, so you know you can gauge it. So yeah, obviously M6 by 1 mil is your standard metric. So I had a look about to see what taps I had. An M14 by 1.25, that would have been ideal if it was M14 by 1. No dies in sort of fine sizes at all. So I've decided I'm going to screw cut the shaft at an M12 by 1, which is an oddball metric, and I'll obviously have to screw cut the nuts as well. I'll probably do the nuts first. I'm going to make some brass nuts, a pair of them. I don't know why a pair, so that I can lock them underneath the stop, I suppose, or lock them together. So yeah, my thinking is make some nuts up out of brass, M12 by 1, and then screw cut a shaft with, you know, that's long enough with M12 by 1 on it, using the nuts as a gauge. So I want to pass the shaft up from the underside of this and lock it in place with a screw. So I don't want to do it, you know, I could have drilled and reamed it 12 mil, but I've decided to drill and ream it 1/2 inch, so that I've got a step on the little shaft. So yeah, that's true with a 10 mil hole. I'll probably go through with something like a 12.5 now. And then I have got this Morse taper, well, a 1/2 inch reamer. Obviously I put a couple of stepped Morse tapers on it to take it up to the Morse taper 3. So I'll fit the Morse taper up in the headstock and ream that out at, or up in the quill, I should say, headstock, force of habit. Yeah, and basically drill and ream it in M12, I've already said, drill and ream it 1/2 inch. I may put a little counter bore on the underside afterwards to stop it pulling up. But I do plan on putting a screw in from the side to lock it in place. But obviously if you're pulling down against a nut, you want a shoulder on the underside so that you're not trying to pull the bolt out of the plate. So that... Oops. Little chamfer on there. So I need another hole over here now. I've marked out where I want it. Let's just come down a touch, I can't quite see. Oops. Little pointer. That's good that way. It's good that way. Lock all the axes. Oh, these locks are awful. These are awful as well, the ones on the front of the table and the ones on the X and Y are horrible. I'm going to improve them. Can you see them where you are? Let me just show you. These locks here, you know, if they're pointing down and you're over the edge of the table, they get jammed and oh, they're just awful. I'm going to improve these. I was thinking of having like a little hand wheel with a hexagon on the end so that, you know, you can hand wheel tighten them, and if you do want a little bit snug, you could just, you know, a little 10mm hex on them. But I think my DRO, when I fit it, is going to go across the front here, so I'm not limiting the rear access. So yeah, I'll probably hold off on replacing those until then. Somebody did ask a question the other day about them, and yeah, I'm holding off to do anything with them, but ugh, they're awful. So as you can see, guys, I've got the only long series cutter I've got that's very small is this little 532. So yeah, had a slitting saw and the wherewithal, I could have used a slitting saw, I could have used a hacksaw, but then why not? I've got a cutter. It's probably a bit wider than I would have wanted, but it'll do. So I'm going to slit this little block down through here, taking it very gently. I think I'm doing 0.2 cuts. Just cutting through. And it's going to take me some time. So probably about an hour down the line, and I've got the 2 slots completed. Yeah, there was 19mm deep with a 5/32 cutter. It was a bit of a challenge, but I just took my time, and yeah, the job's done. So I'll break this setup down now and move on to the next stage. So I've got a 1/8 4th loop, brand new in here. I'm about a mil away from my line, which will allow me to machine the end off as one when I'm done. And I'm just, as you can see, not introducing any vibration or anything into this. Teasing the metal away. To cut through the wall. Now this is going to leave me an 8 wide slot, which will give me access down through with a diamond point on the Dremel to score a line across the glass scale. Now this outer part here is a lot thicker than the back, so I think while I've got the back still attached, I'm just going to machine away the outer part. Let me see how far I need to come. About there. Let me set a 0. Okay. 1, 2, 3, 4. I'm going to go in 4 turns. There. And I'm nowhere near the glass at the moment. I want to cut through the thick part of the extrusion on this outer edge, leaving the thin part intact to support the edge. Obviously this is going to put aluminium particles inside, which I don't want getting on the glass. But I'm cutting it dry, so they won't be sticky, and I should be able to blow them all out when I'm done. think my cutter will be long enough to go through this wall. You get the picture. We're nearly through the thick part now. One more cut. That's through. I'm just looking underneath. I'm 3 or 4 mil above the glass with the end of the cutter. Okay, I'm back up and chop through the thin part.